When we're looking at a quantitative variable, the main thing we're interested in thinking about is the shape of that variable's distribution. The easiest way to see that shape is to look at a graph, and the graph that we're going to use first to see the shape is called a histogram. So, a histogram is a graph that we're going to use to show the distribution of one quantitative variable. What does it consist of? A histogram consists of vertical bars representing the groups or classes of values, just like we had in the table. And the heights of the bars represent the frequency or relative frequency of each class. That sounds an awful lot like our description of a bar graph. There are some key differences between a bar graph and a histogram. The most obvious visual difference is that in a histogram, the bars touch. So if you want to know at a glance whether you're looking at a bar graph or a histogram, look and see if the bars touch. There are other differences, though, that are caused by the different types of data. In a bar graph, remember, the labels were at the center of the bars, but in a histogram, they mark the boundaries of the classes. So when we label the horizontal axis in our histogram, the labels we're going to use are our class boundaries. The other key difference is that in a bar graph, since it represents a qualitative variable, the bars can come in whatever order. But in a histogram, we have to put them in the order that the numbers come in. In other words, they have to come in numerical order. So the process of making a histogram or reading a histogram is very similar to the process of making or reading a bar graph. But there are a few key differences, some of which are brought about by the fact that quantitative data has natural order, and some of which are something that we do differently so that we can understand that we're looking at a shape. So again, this sounds kind of abstract when I just describe it. In the next video, we'll work through an example and actually create a histogram.